Okay, so hello everyone. Thank you very much for coming. I'm very happy to have this opportunity to announce this lecture. It's a guest lecture. We usually have this kind of guest lectures on the campus, but given this COVID situation, so we decided to make this one online. And for those who don't maybe know me yet, my name is Levithan, and I'm the head of web department at SAE Belgrade. SAE Belgrade, as you probably know already, is a university that that has degree centers all over the world in 28, 29 countries, and Belgrade is one of them. And apart from having a web department, we are also having animation department, sound engineering, and digital film department. Now, I'm not going to talk about SAE anymore. I'm also just going to give you a few words about our lecture. And the reason I'm so much happy that we have Stephen Levithan, right? I'm pronouncing it well, Stephen, tell me, yes. Yeah. The reason, yeah, thank you. The reason I'm so much excited is because JavaScript, especially within my students, is a kind of a thing that they are scared about always. You know, when we start, I also have this theory about JavaScript that there is something that is called JavaScript depression. You know, JavaScript depression is how I define it. Is like when you start learning JavaScript and after maybe a month or two, you get so lost that you start thinking, I will never make it. You know, like this is like hell. What the hell is this? But nevertheless, you know, like all of us actually make it at some point, you know, and we have this kind of eureka moment, and we feel happy about it. But then as we progress through our learning, we actually discover how it can be more advanced, how it can be more exciting, how it can be actually more interesting and challenging, and so on and so on. So it is a language that is used in so many different applications in a way. But yeah, I mean, this is one reason. Another even more important reason is that Stephen is actually a guy who has a very admiring career so far. I mean, you're a young person, Stephen, but it's very interesting what things you accomplished so far, and how many of these experiences that you have to share are really exciting. For example, Stephen worked all over the world, I would say, if I remember well, from Silicon Valley to Washington, D.C., Tokyo, and also, you know, one of probably the most interesting employments you had so far is working at Facebook. Now, there are not many people who worked on Facebook, at least, you know, like if you take all numbers, then the number of them is obviously limited. But, you know, like I suppose it's a very interesting experience that you can share with us. So thank you very much. Stephen is also an expert in regular expressions, and this is something that he will tell us about a little bit today. And I strongly encourage you that if you have any questions, or if you would like him to explain something, or just ask, please guys, you can write your questions in the chat, and we can then use the Q&A on the end of this lecture to actually discuss all of your questions. But you can also, you know, like I mean, raise hand if something is really important. Maybe we can even do it immediately. Nevertheless, just try to use this amazing opportunity to talk with him and learn something more, and especially learn about these amazing experiences that he had so far. So Stephen, thank you very much. My great opportunity, and I will pass the words to you, yeah.
Thank you, Vladimir, for the intro. And thank you, Dragan Lucic, for introducing me to Vladimir. It's nice to see you today, Dragan, as well. That's how I got in contact with SAE originally. And thank you all for being here today. I guess I will share my screen. see. All right, can everybody see this okay?
Yep.
Yes.
Great. All right, so yeah, I guess as Davo, everyone, yes, I'm Stephen. I'm very happy to be here. Thanks for attending. I think we have an hour and a half today for the presentation and Q&A. There is time at the end for Q&A like Vladimir mentioned, but please feel free to jump in during the talk with questions and we can make this more interactive. You can raise your hand or you can just start talking. That should be fine. I think we'll have plenty of time if you want to ask questions. So here's a little about me. Vladimir was mentioned some things here, but yeah, I'm a former programmer and manager. My last job was at Facebook, like Vladimir mentioned. I worked there for 7 years exactly, and about half and half as a manager and a programmer. Before joining Facebook, I already considered myself an expert on JavaScript and regular expressions. You can see a much younger me, for example, here in the bottom right with a copy of the Japanese edition of Regular Expressions Cookbook, which is something I authored, co-authored 12 years ago. But I've been in tech almost all of my career. I started as an IT technician, but after a few years, I switched into programming because I thought it was a lot more fun and creative. And I worked around the world, including in Silicon Valley, Washington, DC, Baghdad, Tokyo, like Vladimir mentioned. I'm happy to answer any questions about this stuff later. But yeah, so here's what I'll be talking about today. I'll start with more details about my background, including some fun facts. I'll then go into early beginnings in tech, becoming an expert, and eventually joining Facebook. I was a big fan, personally, of my time at Facebook and Facebook engineering culture and practices, so I'll talk about that and some of my lessons and takeaways from the company. And then if we have time, I'll show some fun and advanced examples of using regular expressions at the end before going into Q&A. Okay, so let's get started. The first fun fact about me, my mom is Serbian, but I never spent any time in Serbia until a couple years ago. For the last 2 summers, though, I've been visiting and I've come to really love the country. Both my visits in Serbia, I've spent a lot of time with a friend, Dragan Usic, there, so, last 2 summers. But yeah, I'm now in the process of becoming a Serbian citizen. My dad, though, is American with a Jewish background, and I spent most of my childhood growing up in Japan, where my mom still lives, so I have cultural connections to many countries. These days, I'm studying both Serbian and Japanese, and although I'm still very much a beginner in Serbian, I'm an engineer at heart. So you can see on the right the Serbian language learning charts that I've created and published on my blog, which I'm biased, but I now think they're the best charts like this for Serbian verbs and cases in the world. So I can make fancy charts like this, even though I can't speak almost at all. But if you're interested in checking it out, there's a link underneath to where I posted them. I didn't mention anything earlier about education because I actually don't have any. I was born into a religious cult, which I can answer questions about later if you're interested. But they had about 10,000 people around the world at the time, and they believed the end of the world would come in 1993, so there was no need to educate their children. So almost everything I've learned has been self-taught. I left the cult on my own when I was 16 years old. And one of my first web projects actually was working with friends to document the cult's history in an online wiki, which you can see here. Earlier this year, actually, for the first time, you can see a blog post here that I wrote from this year, where for the first time I outed myself as the person who stole and published photos of the cult's leader who no one had seen in like 30 years. This was back in 2005. And in the story, I argue that publishing for photos was a turning point that led to the cult's gradual decline. So it's a bit of a crazy story, but yeah, I've included a link here if you're interested to learn more. I also have what's called aphantasia, which means that I'm blind in my mind. It's something, I know, Sagan, we've talked about this before. But yeah, so most people's thoughts and memories include a visual component. Even though the strength of their visual images vary, as is kind of crudely shown in this image. But I'm all the way on the right, so not only can I not see an image of an apple in my mind, but I've never seen any object, shape, or color unless it's right in front of my eyes. My girlfriend is actually the opposite. She's over here. She's very, very strong mental imagery and imaginations. I've learned, though, that most people aren't aware of these differences and assume that other people's thinking and memories work the same as their own. So if this is a new concept for you, or you'd like to learn more, I have a link here in the bottom right. I can share these links after the talk if you want, so no need to take notes now or anything. But if you're interested in learning more, this is an article that I wrote for afantasia.com before. All right. I know this is a lot of details about myself. Hopefully it's interesting though. Here's the last one. I previously held top secret clearance for the US government and learned a lot of interesting things from my experience as a programmer working in Iraq and with a big government agency in Washington, DC. So this helicopter here is how I would fly to different sites in Iraq to help train people on new releases of the software I was working on at the time. But yeah, so a little bit about how I got started in tech. So I was self-taught, like I mentioned. I tried programming for the first time at age 13. By 16, I had a job working for Sega as a video game tester. This was a game I worked on. After saving up money, working in IT, I moved to the United States for the first time at age 19. I was always a geek, I would say, and probably would have been a programmer even if it didn't pay well. But I got lucky that tech is a good career and one where knowledge is more important than formal learning and credentials. That was especially true in the United States. I think that in Japan, at least at the time, I might not have had the same career. I don't know how this compares in Serbia, but yeah, programming in general, because you can do it remotely, because it's much more focused on what you can do. It can be a way to yeah, just have a wonderful career for many people and get started quickly, as quickly as you're able to learn. Cool. So when people interested in programming ask me what language they should learn, there are multiple good answers, but I usually focus on JavaScript, partly because I love the language, and partly because of how easy it is to just refresh a web page on your local computer and instantly see your changes without having to compile, configure a web server, learn a sophisticated editor, or anything like that, unless you want to. Actually, I was surprised, Vladimir, you were saying that JavaScript was intimidating for some new students. What programming languages do you start with, if not JavaScript?
Yes, actually we do start with JavaScript, but I suppose it is because they're first programming language that they are learning. So it's not only about JavaScript as a programming language, but also because it's the first time they see the programming language in their life. So sometimes the reason why it's like that.
Fair enough. And you probably teach good JavaScript practices and make it a little bit more advanced and complicated in how you do it. But yeah, you can use just a notepad on your local machine, load it in a browser without doing anything fancy, no NPM, no Git, no anything like that, and then it can be really easy. But yeah, if you have to learn lots of concepts at once, then it can be more intense to be a new programmer. But yeah, so in any case, this was usually when I talk to people, I talk to people about the benefit of being able to jump in right away and be able to see your results immediately. Similarly for regular expressions, I don't think I would have become passionate about them if there weren't good tools for instantly seeing your results with every keystroke, like in this image here. So this is actually like, for me, this is a very important point. Systems that give you a tighter feedback loop for seeing the results of your changes, they not only save you time, but more fundamentally, they help you learn faster and enjoy the experiences you go, which helps you actually stick with it long enough to build the skills that then keep you going even longer. Otherwise, people just stop doing it. In many cases. So this is an insight I think is important. But yeah, so the efficiency gains you get from shorter feedback loops are just a bonus, really. The real benefit is how they help you enjoy the work more and therefore stick with it. So getting a faster computer or having shorter load times or instantly seeing results, things like that, those are things that pay off with more than just the time you directly save. It actually helps you stay with things and enjoy it. Okay, so about 10 years ago, prior to joining Facebook, I was maybe one of the world's leading experts on JavaScript regular expressions specifically, which is a very narrow niche, but yeah, it was something I was really interested in. So I thought it might be interesting and hopefully helpful to talk about how that happened, despite not having connections in the industry, no fancy degrees, not having worked for any well-known companies at the time. So at a very high level, programming has both generalists and specialists, and people have great careers with either approach, but my focus was usually on being more of a specialist. So many years ago, I wrote a popular blog about JavaScript and regular expressions. You can see a screenshot from it here on the right. I started it long before I was actually an expert on anything, and I was just sharing cool things I learned or came up with. But in order to write about it, I first pushed myself to learn everything about the subject. So for example, I wouldn't just write about how a complex regular expression feature worked in JavaScript. I first learned how it worked in every major programming language to be able to compare it and see if there were alternative ways to do it. And so when you're teaching and putting your work out publicly, there's more, at least for me, there's more internal pressure to really know what you're talking about, so you can explain it clearly and authoritatively. For me, open source was also helpful. I'd publish libraries that I'd write about and learn from others' improvements, bug reports, and competing libraries. One other thing I really loved at the time was the JavaScript language mailing list, which anyone could join and discuss future improvements to the JavaScript language. Some of it was difficult for me to follow at first, especially since I didn't have a computer science degree. But over time, it really up-leveled my understanding of all the edge cases of the JavaScript language, the inner workings of web browsers, and yeah, everything that went into actually building a web browser and building a programming language. So after a few years, my blog started leading to other writing opportunities, including a couple of different programming books, started leading to job reach outs. But yeah, in general, tech recruiters at companies like Facebook and Google and others, they're looking for places that you've demonstrated your passion and expertise, including in open source, in blogs, and participation in industry groups, etc. Okay, so yeah, and as a manager at Facebook, I'd encourage any engineer who wanted to become a deeper technical expert to spend more time helping others with technical problems. In order to help people at all, basically what I was saying before, like to help people, not to mention to explain things well and give clear, high quality answers, you usually have to do your own research and testing first. And in the process, you'll understand things much better for yourself as well. So I highly recommend looking for more opportunities to do code review for other people and really strive to make their work better. You'll not only learn from all of their creative ideas, of course, but you'll also push yourself to learn more in order to give advice. Similarly, if you use Stack Overflow, I recommend don't just ask questions, but also answer questions for others and do some extra work to make your answers high quality. If your company or university has message boards or chat threads where people ask for programming help, I think it would be a good idea to become known for helping other people solve their problems, because in the process you'll learn as well. Yeah, and very importantly, I think, make sure you're always surrounded by other people who are smarter than you. When I worked with government for a few years, I found myself learning less over time because I was often the best programmer on the team. That can give you good job security, of course, but it's a terrible way to learn. And after joining Facebook, I was surrounded by amazing programmers, many of whom were far better than I ever would be. So it again really turbocharged my learning and forced me to carve out new areas where I could build my expertise and where I could uniquely contribute. All right. So let's talk more about Facebook. First of all, any questions so far before continuing?
Not so far, but very interesting.
I have so many questions, actually. I don't know if I'm the only one, but I do. Actually, I'm interested in how did you get all these opportunities in the first place? You know, like from working to the government and you know, like all these companies and becoming a tester for the game. I mean, how did you get to these opportunities in the first place?
So each of them is a different story. Becoming a game tester was a short project. It was only for like a couple months. I basically lied about my age in Tokyo because I was still 16. I turned 17 while I was working there, and they're not really supposed to employ children. So, and I didn't have a working visa in Japan, but you know, I needed money because I was on my own. But so I worked with them for a couple months, and then I found a IT company there where I was a technician, And that place was run by like a couple of crooks. One was from the United States, one was from Pakistan. They needed people who could repair computers. And I worked for them and saved up enough money to move to the United States. Once I was in the US, since I'm an American citizen, even though I didn't grow up in the US, at least I spoke the language and I was a citizen, so I could work there legally. In Japan, I actually wasn't able to. So, yeah. So that's every different situation is different, though. And I moved from Tokyo to Washington D.C. and there I gradually started working more with government contractors and government, because that's what a lot of the work in Washington D.C. is. So there I started working for government agencies and made my way up. And then from there I had connections to military, et cetera. That's why I went to Iraq. But yeah, each one's different.
I got one. What type of programming is done in the Army?
Well, I wouldn't say that I'm expert to answer that question. What I can share is a little bit of my own experience. So there are certainly programmers in the military who are soldiers, but the Army and the military generally can't train enough of them. So they often work with contractors. So they'll hire companies that do this work for them. That's actually what I was doing. So I wasn't a soldier at the time. I was working for a small tech company that was working for a larger company that was providing most of the translation services for the military, the US military in Iraq. So they had about 10,000 translators and linguists working for them. Most of them were actually local Iraqi citizens, and a couple thousand were from the US. And so they spoke like mostly Arabic, but like 80 different languages. And we were writing software for for them to actually work locally with the military and all their operations there. So most of the work could be done from the States, but they had like 3 programmers on the ground in Iraq who could work with the local people there who were actually using our software and get like work with them on their time zone, get requirements for them, et cetera, and train people on the ground, et cetera. So it's a bit of a strange situation to be working in Iraq while working on like HR and translation software, but yeah, that was the situation. Okay, I'll continue. And any other questions, certainly feel free to jump in, or we'll have the Q&A at the end as well. So going back to my slides, the Facebook was actually the only large company I've ever worked at. Although I joined in 2012, so they're much larger today than they were back then. Facebook, you probably have heard, they have wonderful perks, great salaries, but I also really love the culture there. So I wanted to share some of the things that I think help make their engineering culture world-class. I worked on actually lots of projects and teams across Facebook, spanning multiple orgs, including advertising, the Facebook Groups product, and privacy as well was another area. And as I mentioned earlier, roughly half. So the first half of my time there was as an engineer, and the second half was as an engineering manager. In the photo here is a close friend of mine, Juliana, who for several years she held the world record for being the fastest woman to cycle around the world. In the photo here, she stopped at the Facebook office to get her bike tuned up before starting a race across the entire United States. So this was like the start of that, right before she took off. But yeah, so question for the group here. Have any of you heard this line before? Move fast and break things. No.
No.
For years this was a famous Facebook engineering slogan. And the point was not that breaking things is good. You can see here on the photos Mark Zuckerberg on a big developer stage talking about this. But the point was never that breaking things is good, but rather that principles are meaningless if you don't articulate the trade-offs you're willing to make. So that's why a principle that's like, be honest is completely useless, because everyone already agrees that being honest is a good idea. But yeah, similarly, everyone wants to move fast, of course, but if you really value it and want to move faster than everyone else, what are you going to do differently, and how well do you understand the trade-offs that you'll have to make to do that? So a few years ago, Facebook actually changed the slogan to something less sexy that represents that they're a massive company now. And in general, they have slowed down somewhat as they've grown, but they've always been able to move as fast as a company, maybe 10 times smaller than that. I think it's generally held up throughout history. Whatever size they're at, they can ship things, get new stuff out as quickly as a company, maybe 1/10 their size. So here are just a few of the things Facebook invests in and the engineering approaches they take to make move fast more than just an empty slogan. There's many more things I could talk about in the list, but these are a few I figured I'd go into. Number one is continuous deployment, which means that code goes live automatically to the public after it's committed to trunk, rather than waiting for a human-reviewed release process. Actually, when I started at Facebook, they weren't using continuous deployment yet, but they came pretty close. There was a company-wide weekly push of all new code where all of last week's work would get about 1 day of internal testing and fixes before going live. That was already considered ridiculously fast in the industry, but as Facebook got bigger, instead of slowing down and growing more cautious, as most companies do, they thought they weren't moving fast enough. So they did lots of work to be able to move to twice weekly pushes and then to continuous deployment, which makes them probably the largest company in the world that does this for their main products, continuous deployment. Similarly, the Facebook and iOS, the Facebook iOS and Android apps, they've also wanted to continually get faster at releasing those. So before it was like they would do monthly releases, then they moved to every 2 weeks, and now weekly. And they do weekly because that's as fast as Apple will let them release, because the Facebook app goes through complex review by Apple. Number two, don't focus on blame. In my opinion, most things that are called human error aren't really the fault of the person who made the error. The systems behind it that went wrong can and should be made more resilient if it's an important error to avoid. And in other cases, just by understanding and fixing the problem rather than worrying about who's at fault, you not only fix things faster, but also help to encourage a culture where people can make reasonable trade-offs that focus on the benefits of releasing earlier and not just on minimizing risk or protecting themselves. Number three, read and commit to any code. This is something I thought was really cool while I was there. And it's just wonderful as an engineer generally, if you're curious and want to learn about things. It's the opposite, basically, of how things work at Apple, for example, where teams might not even know what other teams are working on, much less have access to their code. But at Facebook, if you're interested in how something works or want to improve something in a product that is not built by your own team, you can just do it. You can not only have access to all the code across the company, but you can modify it, no problem. So you get lots of improvements from other people who are interested or passionate in certain things, or they run into a bug and they just fix it themselves. Number four, monitor repository. So for all PHP and JavaScript code across the company and all products, Facebook actually uses a single repository, which makes it easy to share code across all projects, and it means that updates to shared code go live for all projects simultaneously. I think, I don't have any official stats on this, but I think Facebook's monitor repository might be the biggest in the world. It certainly has billions of lines of code. I don't know how many billions. But Facebook has needed to invest significantly in source control systems and other infrastructure to keep their massive repos working fast, but they consider this to be worth the investment and trade-offs. And then number five, feature gates for easy rollout and rollback. This last one can change your life if you haven't used a similar system before. So I wanted to talk about it in a little more detail on the next slide. Let's see. So here's what I mean and what it can enable. So the code is really simple. It's just like if gates my feature, then run this code, else run something else. And then you can use a simple web interface or even just a config file on the back end to control who passes the my feature check. Whether that's based on like user IDs or query params or percentage of users or countries or whatever fancy and interconnected constraints you want. But using this simple pattern provides a ton of benefits, some of which I've listed here. Excuse me. So number one, if you want someone to test an early or incomplete version of a feature, you can just enable it specifically for them and it will work for them on your test site or even on production. No need for them to check out a branch, build the site, etc., or anything like that. Number two, so dog fooding, if you haven't heard the term, is when you use an in-development version of your app day to day and not just when trying to find problems. So using gates can help your company or team do more dog fooding because you can force them into early versions of features even on their production site. So there's no way out of testing things and reporting problems they run into, etc. Number three, it can make collaboration across multiple developers easier and faster because everyone can see the gated features in code and write code that takes the upcoming changes into account, rather than having different overlapping changes in like completely separate branches. And since everyone is committing directly to master, everyone can just rebase their diffs on master and never have to worry about merging days or weeks of work all at once with bad merge conflicts. So gates also give you easy kill switches where you can disable specific features or pages when there's a problem without taking everything else down. So that would just require you to wrap those features in a gate, and then you can turn them off for all public users if there's ever a problem. And gradual rollouts and rollbacks are even more powerful than kill switches. So I guess for some background, at Facebook, nothing is ever launched to 100% of users all at once. Instead, you might launch your project to 10% or 20% of users, then monitor your logs, monitor your error reports, make sure nothing unexpected happened, and then if things seem okay, then you continue rolling out to 50% or 100%. And then finally, number 6 here, when you have the capability to do rollouts to percentages of users, you can also get A/B testing functionality mostly for free, just a little integration with your existing login system. And if you have questions about that, I could answer how that might work. But yeah, so at Facebook, there are like literally thousands of features being gated this way at any given time. So essentially everyone using Facebook is getting a slightly different version of Facebook products with different features, tweaks, optimizations, and experiments enabled. So they call their system for this gatekeeper. And here in the top right is a photo of an old version of their tool for setting up a new gatekeeper and choosing between many different types of restraints. You can see like options here, like it's a launch based on age or browser or country or data center, or whether they're an employee or whether they have more than this many friends, or all kinds of different things. And then within these things, you'd be able to launch like a percentage of people with users with that. And you can set up like very complex restraints where one restraint is tied to another one, or one gatekeeper is tied to another gatekeeper, and so on. This is a really old version of the tool. They have more sophisticated versions now too. Yeah, so in case you're interested in building something like this for yourself, I've included some notes about how it can work. It can actually be really simple if you have just some basic types of restraints. So first, checks run on the server. So any gates that need to be used in JavaScript are pre-computed and made available to the client as Booleans, which might look something like this in the bottom right. So by pre-computing and then running it as the first JavaScript file, it's then available to all your following JavaScript. Results are fast, and they're always the same on the client and server for the same users. You can see here JavaScript is just getting an object with property myFeature set to true. In advance, it doesn't have to do a check. So the function gate here would just return the value true here. And that whether it's true or false would actually be calculated in PHP or whatever else on the server. Simple check where you can figure like, okay, what user IDs will it be true for? What if they have this query param on is true, et cetera, whatever your restraints might be. Yeah, so making this work on the server for things like user IDs, query params, and Boolean true false is easy, and you can probably imagine how that's done. But adding the ability to launch a gate to a percentage of users. So if you want to build that, I have some notes here on how that would work. But basically, is everyone still able to see this okay? I'm getting a note that my internet is unstable.
Yeah, it looks fine.
Cool. All right, cool. So yeah, if you wanted to build like launching to a percentage of users, then what you do is you'd start with some stable data like user ID. And then since you don't know the upper and lower bound or the distribution of active user IDs, what you can do is use a deterministic hash on the ID and then bucket the resulting hash into one of 100 or more buckets, and then determine the percentage of user, determine the percentage that the user falls under from that hash, which is like it's a random value that you could determine in advance, like what properties make it fall within like 1%, 2%, 3%, 4%. So just one additional thing though, like since you don't want the same 1% of users to always pass all your percentage-based gates, you should use a different salt for each gate when running deterministic hash. Any questions about gating, or should I move on?
I have one question regarding deployment. So you mentioned that Facebook deploys once a week or like a few times a week. What sort of stuff?
Now, sorry, just to jump in. Now it's actually continuous deployment. That's where they were before. Now, when you write code, you land it within like a couple hours. It's live to the public. Okay,
and what sort of stuff would Facebook work on? Because as a user, I don't notice many new features straight away. So what are the general type of stuff that Facebook like what type of code is generally like pushed on a day-to-day basis, if like percentage-wise, if you had to say?
They have tens of thousands of engineers, so it's a big question. They certainly have many products beyond just Facebook. I mean, they have Facebook and Instagram and Messenger and WhatsApp and lots of virtual reality products and a number of smaller products. They have advertising products. They have things that are running on the server. They have all their systems for optimization and their machine learning systems. And we could talk probably for hours about all the systems going on. Within Facebook itself as well, there are many features that you might be less familiar with, depending on how deeply you use the product. So it's not even there's more basic user features, but you might not realize how deep some of that stuff goes. Like there's different systems for live video versus Facebook groups versus like joint video watching versus like there's a ton of things actually in there before you even get into the stuff that won't show up in your newsfeed. But yeah, I mean, everything is being changed day to day. They have. Sorry if the answer comes across a little dismissive. If you have more specific questions, I'm happy to get into it as well.
No, that's all right. I was just curious. So like optimizations and basically everything across the board, whatever they can be. Okay, that's fine. Thank you.
I just have a question. What did you used to work on Facebook? Like, what was your team responsible for? If that's okay to ask.
Yeah, for sure. Sorry, just real quick in response to Nicola's last question. Yeah, most of the day-to-day work would not be shipping brand new features, right? So maybe this helps answer your question more directly. Most work day-to-day would be optimizing things, right? Getting like 1% better metrics on this thing, 2% better on this thing, and so on. It's like a constant experimentation and optimization and so on. Yeah. Rather than constantly shipping brand new large features. William, for your question, what did I work on? So I spent a while, maybe like 5 years in the Facebook advertising org. So I worked on tools that are used by advertisers to buy and manage their ad campaigns. So everything from very small mom and pop advertisers who maybe have a Facebook page and just want their posts to reach more people, up to very large sophisticated advertisers like Nike or Coca-Cola or whoever. So lots of work on the front end products and UIs used to build and manage the systems. I also spent a year working on, so yeah, within that there's many different teams, but the details were, we can get into that if it's helpful. But yeah, so I spent a lot of time on advertising. I spent about a year working on Facebook groups. So groups is, for people who aren't familiar, there's, you can post stuff on your own profile and you can see stuff in newsfeed, but there are also what's called groups. And those are basically communities where you can, some of them are open for anyone to join, some of them are secret, some of them are closed, you have to be approved. And in any case, there are various, there's probably millions of these communities called Facebook groups. So I worked on Facebook groups for a long time. And then my last year at Facebook, I was working on their privacy systems for protecting data and data sharing and so forth. So yeah. Any other questions? All right, so moving on from gates. But yeah, as soon as I left Facebook and wanted to work on code in any sort of collaborative system, not having a Gatekeeper, which is Facebook's system for this, available was instantly like, I really want this. So this was something I really appreciated all there. And yeah, so like all of their development practices are kind of based around this, the idea of continuous deployment, the idea of not having branches. All workflows are based on rebasing rather than branching and merging. And so everything is just always constantly live. And there's never one version of something. There is many versions of things because there's many experiments running, and all the code, you can see it all like together, and you're always working around existing gates and so forth. Okay, but moving on. Yeah, so hopefully that made you interested to try or consider gating if it's not something you've used before, but I'll come back here to basic engineering culture. There are a few other aspects here that I really liked. I figured I could talk about. One is that Facebook has actually a unique hiring process that I haven't seen at any other companies. When you start, you take about 6 weeks to learn about the company and code base, but also to get to know all the teams that are hiring. Everyone then chooses their own team within Facebook. You're never assigned to a team. So that means that everyone is working on something they're interested in or where they think they can have the most impact. But a less obvious but equally important outcome, is that teams that work on low impact projects or have bad engineering culture will naturally struggle to hire new engineers because engineers all choose their own team. So teams have to focus on being a good place to work in order to be successful. That has many cascading benefits. This is also helped out by the fact that you can move between teams pretty easily. That might be true at other companies as well, but Facebook actually takes us a little further, and they actually encourage people to, like, if you haven't changed teams after like a year and a half, they'll encourage you to spend maybe 3 months on another team with no obligation to move over, and you can move back to your old team if you prefer. So they make it easy to move around as well. And number two, becoming a manager at Facebook is actually not considered a promotion, but a parallel career track. And this isn't specific to Facebook. This is more like Silicon Valley engineering culture. So a lot of the good tech companies there will do this the same way, but it's not something I experienced outside of Silicon Valley. So you can continue to get promoted and paid more as an engineer without ever switching into management. They do a lot of work to make sure that you can become like a super senior engineer who's basically compensated at the level of VP, even if you are having that level of impact as an individual engineer. So you never have to switch into management. So the people that go into management are people that actually have the skills and interest to do it. And in fact, it's common at Facebook for people who've been managers for a few years to switch back into engineering if they prefer their role as an engineer. And yeah, number three, although there are engineers who prefer to focus mostly on coding, you're also free to define a lot of your own role and help drive the direction and vision for your product or team. That's something that I've thrived a lot in, because I think of myself more as like a product engineer who's interested in everything from design to usability, UX, and like how to make sure like large complex systems work simply together in the overall like product management side of things. I think is something I'm interested in. So this was something I really enjoyed there. Yeah, let me actually jump to the last one. Evolve complex systems incrementally. So this is not an explicit part of the culture, but I found it was one of the best ways to be successful at Facebook, so I wanted to talk more about it here. All right, so by this, I'm talking about the difference between taking an existing product that already has adoption and trying to rebuild a brand new thing to replace it from scratch versus evolving the existing product slowly via many small changes. Sometimes it seems like rewriting is the only way to achieve your vision or fix some big problem. But in practice, it rarely goes as planned. I've been involved in these kinds of projects many times over my career. It's never as clean as you like. Things end up taking longer than expected. And as a result, since you still usually have deadlines, even if those slip, it's still like there's never enough time to do things. It takes much longer than you anticipated. It is more complex than you realized. So as a result, you make a lot more compromises than originally planned. So the system you end up shipping is not as good as you hoped in the first place. And then it ends up like, maybe a year later, you're back in the state where you're considering rewriting again anyway. So how do you actually change big things incrementally? For me, I think it's crucial to split big projects into milestones that can actually be launched, and then actually release those milestones and measure results along the way. So it's not just breaking up a big project into milestones, but they have to be milestones that you can actually ship and measure them and see that we're actually able to ship this. It has these, it's at least stable in metrics, or it's making things better, and continue incrementally evolving like that. So Facebook has, and during my time there, I mean, I saw personally, they like relearned and re-forgot this engineering lesson many times. These are just a few examples. In the early days of Facebook, for example, there was a big project to rewrite all of their PHP and Python. That failed since there were too many moving parts, and it was impossible to catch up with incremental improvements being made on the PHP side. But what was successful was the hack language. which incrementally evolved PHP to make the language better, faster, more consistent, and more secure. And for some years now, Hack has been a successful open source programming language, and it's replaced everything PHP used to be used for at Facebook. Yeah, there are a variety of other examples here. For example, Lightstand was a big project to replace the Facebook.com website with both new UI and new infrastructure at the same time. Since the metrics didn't perform as well as the version it was replacing, though, it was eventually abandoned. Some parts of the project were able to be reused in Lightstand, but on the whole, the project failed so badly that the Facebook.com website stagnated for years, really, until another project named Comet came along in 2018 that was able to be incrementally adopted. Counterpoint to this, it's not always so simple, so black and white. Counterpoint is that, like, sometimes you do need greenfield projects where you start from scratch in order to escape local maxima. But in my experience, that's much more likely to succeed if you can adopt the new system incrementally and don't have to freeze development on the existing version and replace it all in one shot. Another way to think about this, like, sometimes building prototypes from scratch can be a good way to learn. And if you treat it that way, then although those prototypes don't often ship in their original form, you can extract core ideas and technology from them and inject those into your live projects. So you could think of that kind of as like using the experimental project as a scratch pad. However, if you take this approach, there's usually a strong temptation to try to launch such things as their own products, which then leads to the problems I mentioned earlier. So yeah, in general, like, this isn't always true, but in the end, I've found that usually you'll improve your core metrics more if you spend the same time that you would have rewriting something, if you instead spend that time incrementally evolving your existing product. Which might be obvious in some contexts, but as engineers, often we just want to start things over. We don't understand the old system. We'd rather we think we can make it much better. We don't realize how complex it was and how much work went into handling all the edge cases and everything else, and how hard it will be to actually replace everything. But yeah, so here's a case study on the point I was making for a project I helped to lead. So a long time ago now, Facebook advertising had two giant products called Ads Manager and Power Editor. Ads Manager was designed more for small and medium businesses, and Power Editor was designed around large advertisers who might be working with hundreds or even thousands of ads and ad campaigns. So both of these products were generating billions of dollars, and both had large numbers of users, but each of them had very different ways of doing things. There's a reason there was two products, but having two products had, it was originally intended to help users by having two that could specialize, but it had big problems because advertisers often had to learn and use both products anyway to take advantage of the product's different features. And Facebook teams had to design, build, and maintain both products, which slowed things down. So for years, Facebook wanted to change this. Their first approach which started before I got there. They tried deprecating Power Editor in favor of Ads Manager. So they would just make all new improvements to Ads Manager and leave Power Editor to slowly die. But during that period where Power Editor was deprecated, large advertisers became more important, and Power Editor actually increased from about 15% to nearly 40% of all Facebook revenue. So once we acknowledged that Power Editor wasn't going away, we then had to spend a long time building it back up from an outdated code base and outdated feature set. That was a lot of extra work. Then we spent more than a year with maybe 70 people building a new product to replace both. And internally, we called it New Ads Manager. So this is sort of the rewrite approach that I was saying often doesn't work. So it was called New Ads Manager internally. But unfortunately, when we asked Power Editor users to switch to New Ads Manager, most of them wouldn't because it was too different from what they were used to, and it still wasn't as focused on some of their advanced needs. So by this point, it was several years later, Facebook still hadn't made progress on going from two products to one. That's when I started a new project that took a new approach that was successful in the end. So over the next 2 years, we incrementally evolved the UI and infrastructure for both products to bring them closer to each other step by step. And in the end, users didn't even notice that we completely replaced Ads Manager with an evolved and rebranded version of Power Editor. And we didn't need to ask anyone to move over because it was just a small change at every step from what they were already used to. So the headlines that I screenshotted here, not as exciting maybe as if they said Facebook built a brand new product. It just says, oh, they're including some new features. It's actually the result of like a lot of work where we actually entirely replaced Ads Manager. We didn't just move over a few features. The headlines actually showed, though, that we were successful in our goals of what we set out to do. And all of this had to be done while maintaining all core metrics, including revenue, number of advertisers. And in the end, our incremental approach succeeded with a smaller team than the project that failed while attempting to rewrite everything with a larger team. So hopefully one real world example here that's interesting to consider. That's actually it for my main presentation. I can, with the remaining time, I was thinking to go more into regular expressions. So what? Any questions so far on the slides that I talked about? Vladimir, what do you think? Should we go into regular expressions or stop here for Q&A?
No, I think we should proceed with the regular expressions. If you don't mind. I mean, I actually do have lots of questions, but I just don't want to waste more time, so let's keep it for the end, actually, and ask. But it's a very interesting. I'm kind of puzzled. How do you manage to coordinate all this? It seems like 70 people working on a particular project, which is just a small project out of some bigger project. How do you coordinate all these things? It sounds scary.
Yeah. So that was part of so at that time I was a manager already, and it's part of the challenge of being an effective manager. So, but yes, there's lots of things we could talk about. But fun. For me, I like these big, complex, hard challenges where it's not obvious there isn't one right answer for how to do it, and you have to think about trade-offs for different approaches.
For sure, yeah.
Cool.
Let's proceed for regular expressions then. I think, guys, you agree, right?
Yeah, definitely.
All right. So actually, can we do a show of hands of how many people are familiar with regular expressions? Nicola, Nevin? Yeah, cool. Okay, so some of you. Have you written? So have you written regular expressions before as well?
Yeah, but very, very basic, very basic. So I have to, if I want an email regular expression, I'd probably Google it. So
Right. And you probably find lots of bad answers to that. So it can be a little dangerous to copy and paste regular expressions because a lot of times people Google for them because they don't know how to do it. But then the problem becomes, because you don't know how to do it, you don't know how to evaluate the quality of the answer given.
Yep, that's correct.
Cool. Well, makes sense. That's how it is for most people. Even people who have been programming for decades and they're excellent programmers, often regular expressions are a little bit scary. I don't think it has to be. But maybe I don't think I'll be the best here at making it not sound scary, because I kind of wanted to show some fun and advanced examples. So for people not familiar with regular expressions, they're called regular expressions, regexes, regexp, there's a variety of names, but they're basically a powerful way to search through text for any sort of patterns you can come up with. And they're useful for many things like data extraction, data validation, data transformation. You can use them not only in code, but also in text editors. Any programmer's text editor has a way to do regular expression search and replace. You can use them also in the command line. So there's lots of ways you can use them. They're in basically every modern programming language, although the flavor of the exact syntax used for regular expressions varies from place to place a little bit, but it's usually pretty similar. Here's a comic strip about regular expressions from XKCD that I love. I'll give you 20 seconds to read it for anyone who hasn't already looked over it. Yeah, so basically you can see hero swings in, writes one line of Perl code with a regular expression, and solves what previously seemed like a very complicated task. And that's how it can often feel when you're writing regular expressions, that you're like some crazy wizard who has magical powers that no one else understands. And then, you might not be able to understand if you try to read your regular expression the next day. In any case, yeah, if you're less familiar with regular expressions, I apologize, but I won't actually be doing a tutorial here. Rather, I thought it might be cool to show some advanced examples to show what you can do. So to start, here's an example of using a regular expression in JavaScript. So we have a function here called Fahrenheit to Celsius, or F2C. Creates a regular expression, does a search and replace. Before going into the code here, let's look at the results. So we run it with this value 98.6 F, and it gives back the Celsius value. But we could also give it a longer string or an entire document, and it would convert all Fahrenheit values to Celsius in one shot. You can also see here that it's any number that is not followed by F is left alone. So it says main 9 pi is 4 Celsius. So it can process an entire string in one shot and do everything. So let's look at how this works. You can see the code is very short. If you're not familiar with regular expressions, this might look hard to read, but it's actually not so bad. So what's happening here is, so we create a constant, regex. This is the syntax for creating a regex. It starts with a slash, ends with a slash, and then has flags afterwards. So here the flag G stands for global, which means search and replace all matches and not just the first match. So then inside the slashes, we have the regular expression. It basically says optionally match a hyphen for negative values, then match one or more digits, numbers, and then optionally match this subgroup here, which matches a decimal point followed by one or more numbers. So you can see this whole thing is optional, so it won't match just a decimal point with no numbers after it. It'll only match this if there is a decimal followed by one or more numbers. And then after that, it matches the letter F, and then a word boundary, which means this F cannot be followed by other letters, so it can't be part of the word fun, for example. Only word matches when the F is on its own. So that might still be tricky to understand exactly what's going on, but hopefully it shows that this is actually pretty easy to break down part by part if you know what they mean. And then here's what it does. String.replace, search for the regular expression. We're going to search for all matches because of the G here. And then our replacement value is actually not going to be a string. Our replacement value is going to be a function. So the function is getting two arguments here. First is the entire match. The second is the first capturing group, which is captured by these outer parentheses here. So it'll be the number excluding the F. And we're calling this num here. And then we return, this is just the formula for converting Fahrenheit to Celsius. And it returns that. And so with this search and replace, in one operation, it will update all values in an entire string. Clear enough? Any questions?
Yeah. I didn't know that. So this callback function that has the num variable. So does it basically? Could it also extract the F figuratively, like if we added?
You could, absolutely. So to do that. So what's happening here is every set of parentheses is a capturing group. So it not only groups things. So here you can see this question mark is being applied to the entire preceding group. Question mark means match 0 or 1 time. So basically it makes it optional. So here the grouping is not only used for something like that, where you can like repeat an entire group, it's also used for capturing and remembering the value. So we have two sets of parentheses here, which means there's actually a back reference 1 and a back reference 2. Here we're only using back reference 1. So we could pass in a third argument to our function, and the value of it would be the value captured by this inner parentheses. If we put a third parentheses around the F, then the third back reference would be just the value F. Okay. Yeah. Now there's a way to use grouping that does not remember the value, so it doesn't create these arguments. I didn't show that here just to make it a little simpler. But if you, because like for example, this outer grouping I want to capture because I want to use it here as num, but the inner one I don't need to capture. I just want to have a grouping here and it doesn't need to capture. So there's a way to do that as well. You just change the opening parenthesis. But yeah, so anyway, you can see this works really simple. When this kind of thing works, you'll often find that you can take like 100 lines of code or 200 lines of code and replace it with 1 or 2 lines of code. And it's actually not that hard to read, although it does take some time to to learn this. And maybe, but like putting some comments here about what's going on would actually make this pretty understandable. Even if you can't read them, I guess. Okay, so for learning regular expressions yourself, the it's really hard to learn regular expressions without using them and seeing the results for yourself. I can explain it a little bit, but really the way you'll learn is not to read a tutorial. It's not to have someone tell you, and it's not to read documentation, but it's to play around with it and see the results as you make changes to the regular expression, as you make changes to the input string. So if you don't already have a favorite regex tester, this is an excellent one that I recommend, regex101.com. I'll show some examples inside this tool, but yeah, you can go here on your own. You can save your own regexes in there, but also the good thing about it is as you type, it'll quickly show results. Let me switch over here. Can you see this okay?
Yep.
In the regex tester? Cool. So for example, this is our test string. In a regular expression, a dot matches any character that is not a new line character. So it won't match like line breaks, but anything else. And so you can see here, as I type that, you can see all the matches. 2 dots, you can see the matches change, etc. So this is a great way to learn. It's just to play around with regular expressions and see what happens. So let me close that, and I will go back to my examples here. First one, to delete repeated words. So check this out. So we have a regular expression. I'll explain that more in a second. Here's our test string. And then we do a search and replace here. So our replacement is $1, which is the first capturing group. So by doing this, you can see we go from this, where we have some repeated words, to here where there's no repeated words on the bottom. This is a repeated word, and here's another. You can see it works for any number of repeated words, but it doesn't match things where it's separated by different words. So like is doesn't match the second is, but it will match if they're next to each other, right? It also, like, they have to be separated by a space. So is right. So some basic. Let's see how this regex works. So first it matches a word boundary, which is a position where there's a word character on one side and a non-word character on the other side. So this is what's enforcing that it be a whole word and not just part of a word. Then we /W is for word character, plus means 1 or more times. We put this in the parentheses to capture and remember the value so we can use it in our substitution here, in the replacement. So we have the first word in capturing group 1, and then we match the subsequent repeated words here in the second group. I mentioned before you can do a grouping that doesn't capture and remember the value. This is how you do it. You have opening parentheses, question mark, colon, and then it's a non-capturing group. So inside the non-capturing group, we match 1 or more white space characters, followed by /1 is a back reference to whatever was captured inside this group here. So match the same word, and then followed by a word boundary, and repeat this 1 or more times so it can match as many times as the word repeats. Okay. Does that make sense? More or less? Anyway, yeah. You can see it working here. Cool. So we've got a simple substitution, and then we get our output here. Let's look at a similar example. Delete duplicate lines anywhere. So the last one I showed that if there was a word separating 2 other identical words, that wouldn't match either word. This one's different. This is more advanced. This will match any entire line where that same entire line appears elsewhere in the string. So they can be separated by other lines. The lines can be as long as you want. So it can be like, this is a whole sentence. And then if we repeat that over here, as soon as it has an identical match, then it matches the first one and not the second one. This is so that we can replace. You can see I'm doing a search and replace here as well. My substitution string is just an empty string. So replace it with nothing whenever there's a match. And then the result is here. So we have all the unique lines on the bottom and no duplicates. So you could, if you had a text file or something, or your logs or something like that, and you want to replace all duplicates with nothing and just have all your unique lines, this one regular expression will do it for you on the whole document. So what is it doing? This is pretty, some of these concepts are advanced. I won't explain all the regular expressions in full detail, but let me go through this really quickly. Caret matches only at the start of the string, or because I have the M or multi-line flag turned on, it also matches at the start of any line. So this match has to start from the beginning of a line and continue to the end. This $sign here means the end of the string or the end of a line with the M flag. And then what we do is we match dot matches any character that isn't a line break character. So this will match the entire line, we say one or more times, capture the entire line, capture it to capturing group 1 with these parentheses, then match a line break character, and assert, this is what's called a positive look ahead, which doesn't match anything on its own, but it asserts that at this position, this thing needs to be able to match. And don't consume it as part of the match, but at this position, there needs to be this thing ahead of it. So what it does is then looks through the rest of the string to see if it can find the same thing that was captured in this, but it doesn't make it part of the match. It just matches the first line here. Anyway, we could go into the details, it would take a little while, but the basic idea is it matches a whole line and then looks ahead further in the string to see if that line appears again. If so, the match will pass, but it won't include those later lines. So like, because if it matched from the first line all the way to the line where it appears, then it would match all the lines between as well. And we don't want that. We just want to replace the lines where it appears where there's a duplicate later in the string. We'll match anything as a duplicate later. And here's what we get. Cool. Any questions or move on? I'll move on. Cool. I know some of these may be hard to like actually understand what's going on in full detail. So maybe one way to think of this is just to see like some of the range of things you can do with regular expressions that maybe you didn't consider. Here's another one, password complexity. So in this case, this isn't necessarily the best programming practice. It's probably easier to do these checks independently, but this is an example of using one regular expression to check multiple conditions at the same time. So with this one regular expression, we can check whether a password is complex enough. And the rules here are that it has to have at least 8 characters, it has to have at least 1 digit, it has to have at least 1 lowercase letter A to Z, and it has to have at least 1 uppercase letter A to Z. So it's only matching strings that are complex enough. And it's doing this through, so here at the end, you can see it actually matches dot, which is any character, and it says between 8 and infinite times. So this is where it actually matches the string or the password. And there's 3 look aheads here, which is what I mentioned before, which they are just assertions that this needs to match at this position, but don't make it part of the match. So because these match an empty string, it's just an assertion that says true or false, we can stack as many of these assertions as we want and just apply multiple rules to the regex. That's how it's able to check multiple rules simultaneously. So we search ahead, we say it can be, the A to Z doesn't need to be right away, but it can be after any number of other characters, but there has to be an A to Z in there somewhere, and then there has to be a lowercase A to Z in there somewhere, and there has to be a digit in there somewhere, and then match 8 or more characters, and it checks all 4 rules at once. So kind of cool if you've never seen something like this before. Again, this might not be how you actually want to code something like this, but in some cases it's useful if maybe you're just given like some APIs will give you like, you can use a regex to do some validation, but that's all you get. You can't write custom code. And then you can do something like this and apply multiple rules all at once. Let's look at another example quickly for reversing the order of names. So here you can see names like John Smith, Robert Downey Jr., et cetera. On the bottom, you can see what they get turned into. So then we have last name, comma, first name, and so on. And it's handling advanced things like suffixes like junior or the third. It handles it whether there's a comma in front of the suffix or not. It handles non-letter characters inside names, compound names, all these sorts of things. So I won't go to the details of this one here because some of the mechanics will work similarly, but you can see with just one search and replace, I might have a document that has a ton of names listed. I want to switch them all to last name, comma, first name. With one regular expression, I can do it all in one shot. Here's the substitution and reply. So here we're using multiple capturing groups and changing the order that way. So 2 was the last name, 1 is the first name, 3 is the suffix if there was one, including the preceding space. Cool. And we insert the comma in here in our replacement string, and that's how it works. All right, close that out, close this. Next one, insert thousand separator. So this is an example of, like we were saying earlier, for changing Celsius to Fahrenheit. If you try to do this using more typical code without a regular expression, you'll probably write a lot of lines to do this. With a regular expression, you can do it in one line, and you can apply it to an entire document all at once. So here, these pink lines are where the matches are. It's because the regex actually matches empty strings at positions where you want to insert a comma. So we're doing insertion replace. We search for these empty string positions. We replace the empty strings that we match with a comma, and then our output is beautiful. Every single number is handled perfectly. We put the commas in the right places. For 1,000 separators, it does not put commas into numbers after a decimal point. It is able to handle numbers that have following letters, intentionally ignores numbers that have preceding letters because they might be like product names or something. It leaves alone numbers that already have commas inside them. It can handle numbers within strings, etc. So you could apply this to an entire document all at once. Whether you give it one number or an entire string, it will put the 1,000 separators everywhere. So here, this actually won't work in every programming language. It works in JavaScript and it works in .NET languages because of one thing it's doing here, where it is using a look behind, which is similar to like a look ahead, where I was saying it's an assertion that this thing has to follow, but don't actually match it. A look behind is the same thing, but in reverse. So this thing has to precede the current position, but don't actually make it part of the match. And because we use a look behind that is a variable number of characters, so here this plus says one or more, so up to infinite times. Not all programming languages support infinite number of, like a variable number, variable length match inside the look behind. But this will work in JavaScript and any .NET language. And there are ways to do something similar, just wouldn't be as simple in other languages that don't allow this. So we're looking for numbers that are preceded. It has to be preceded by a digit because we never put a comma right at the beginning. It has to not be preceded by a dot or a letter in any language, followed by one or more digits. So if there's a letter before the preceding digits and we don't want to match here, and then it has to be followed by, so these are this is a positive look behind, negative look behind, positive look ahead. So it has to be followed by digit, 3 digits, and the entire group is repeated, so in multiples of 3. And then at the end of this set of multiples of 3, there can't be an additional digit. In any case, so we're saying these have to be behind it, these have to be before it, and then we perfectly match the positions where commas should be inserted. We just replace our empty strings with a comma, and it handles everything. Another one. Some people think regular expressions aren't able to do this, but this is an example of using regular expressions to match a recursive pattern. So here it will match balanced parentheses using recursion for any number of parentheses. You can have other characters inside of it, etc. It all works great. And this is actually quite, so right here, this R, parentheses, question mark R, is the recursive part, so it says everything on the outside of this, just apply it recursively right here. And this allows you to very easily do recursive matching with regular expressions. This syntax for question mark R only works in PCRE, which is the regex language used by PHP. So you can do this in PHP, you can do it in Perl, but most other languages you can't do this. .NET actually has .NET languages like C# and Visual Basic .NET have a different syntax to do the same thing, so they can also do it, but other things like JavaScript and Python can't do recursive matching. But when you can do it, it's pretty cool. You can come up with like really simple regular expressions that do really advanced stuff sometimes. The last example I can show in, let me switch. So this app, regex101.com, can work with like PHP regular expressions or JavaScript, but it can't do .NET. So let me switch what I'm projecting here to a different app where I can show a .NET regex. Okay, can you see this? Okay, this is using, I won't go into all the details, but what this is matching is any palindrome. So a palindrome is a string that is the same forwards and backwards. So A is not a palindrome, but AA is the same forwards and backwards. So is ABA. So whether you start from the beginning or at the end, it's the same string. AABB is not, because if you start from the end, it's BBAA, and if you start from the beginning, it's the opposite. So that's not the same forwards and backwards. Redivider is a palindrome. Taco cat, if you ignore the space, is a palindrome. And amazingly, this one here as well, a man, a plan, a canal, Panama, this is a palindrome. So it'll match anything that's a palindrome. And it does it with an advanced .NET regular expression feature where it's actually like adding matches to, instead of just capturing a match, it's adding it to a stack called char here, and then it like removes things from the stack, and it does some fancy fun stuff. But if you, most people who've used regular expressions in .NET don't even realize this feature exists, but you can do some crazy stuff like this. Anyway, let me stop there. Happy to answer any questions about regular expressions. This was meant to be more of just showing like what sorts of things are possible rather than actually teaching it. But if you have questions about it, that's great. And hopefully, if nothing else, it inspired you to learn more about regular expressions. But yeah, that's it for my presentation. So Vladimir, how do you want to do like Q&A?
Yeah, I will start if possible. Thank you very much. I mean, this was so much interesting, and I really have like 1 hour of questions. I will not ask them now. I hope I will have more opportunities for that. But generally, what I wanted to ask you regarding regular expressions is like, I saw many times some kind of libraries online, because obviously lazy programmers don't want to construct the expression themselves, and there are these websites with all the, you know, like snippets of regular expressions for this purpose, for that purpose, you know, like similar things. But what also happened to me is that I just copy something from somewhere, it doesn't really work, you know, or it doesn't really work for any case and so on. So I was not really able to find something that is reliable enough. And this is the moment when I actually started learning regular expressions more seriously by myself and figuring out how they work and try to create more complex scenarios and so on. But I was not really even aware that you can do recursion in regular expressions, and some of the things that you showed are really, really impressive. But nevertheless, you know, like, do you know maybe some source that is good enough? What do you think about this?
It's a good question. I wish I had a better answer for you. There are many projects to create these kinds of libraries. The problem is there's lots of crap regular expressions out there, and these libraries tend to be filled with a mixture of quality. So it's hard to recommend them. Regular expressions can even cause performance problems if you do certain things that are that can be easy to do if you don't understand things deeply. So there can be some risks for using bad regular expressions if you have like nested recursion inside multiple groups that all have like infinite, or sorry, not nested recursion, but nested quantification, like repetition. So if you have like repeat something infinite number of times, then you put that in a group and repeat the group infinite time. There's certain ways of setting things up that can lead to like really bad performance problems. But then they won't always be obvious, because it will work fine when it matches, but sometimes if you create like a maliciously crafted string, which almost but doesn't quite match, then it can cause performance problems. This is called a REDOS, or regular expression denial of service. So for that reason, because, like, you shouldn't worry about this too much when you're writing simple regular expressions, but like, there are some concerns about using other people's regular expressions that you don't understand. It's usually better to, like, yes, Google for it, see something that has a lot of upvotes or whatever, so it's probably pretty good, but then try to understand it yourself. And try to understand, like, put it in a tester like regex101.com and write your own test cases. Write lots of things that should match and should not match, and make sure it matches everything you expect in the way that you do. And then with that, you can have So there is one recommendation I can make, which is actually the first book I co-authored, which is Regular Expressions Cookbook. This is the whole point of the book. It gives you like a couple hundred different problems of things you might want to solve with regular expressions, and then like the best answers for them in the world. I don't actually recommend the book these days, because it's like, the second edition was written in 2012. We haven't updated it. It's good. You could get it if you want, but I don't know, like, it doesn't support the very latest features of regular expressions in JavaScript or other things. But it's actually designed to do exactly this. What is a high quality, authoritative, trusted source for like solutions to the problems I might want to do with regular expressions? So I can recommend that. That sounds a little bit like biased, but other things can be a mixed bag sometimes. And I'd recommend actually playing with it.
It happened to me actually to copy something, you know, without really understanding everything of it, and then it turns out to produce a bug, you know, like after some time, because I maybe didn't wrote too many test cases, or, you know, like I haven't tested it enough, and I realized that actually it's not even just. Then I regretted that I used it in the first place, but instead I could write some code that I could understand and solve the problem. Yeah,
exactly,
but thank you.
Yeah, that makes sense. Well, here's what I'd recommend then. You can Google Regular Expressions Cookbook second edition. You will find free PDFs of it online that have been pirated. You can use that pretty easily. Those recipes, you know, it's framed as like a cookbook with recipes for particular problems. And the solutions it gives, or the recipes, they are they handle like a bunch of different programming languages. So they'll show variations where it's needed to work in different programming languages, and it will also give detailed explanations of how all of them work. So that might be helpful. That's one thing I would recommend as a library for this.
Thank you very much. Guys, please, your time. If you want to ask something, this is the opportunity.
Yeah, I have a question. I wanted to ask, what got you into learning regular expressions? Because I started learning it like a year ago, but it seems very intimidating, so I just kind of backed out of it, to be honest. So what really got you to go into it this deeply, really?
Great question. I actually covered this a little bit in the talk. So I started out needing it for some work. Like at first I was doing like form validation on things. I was a junior programmer, you know, and I was doing basic stuff. And then I would see like some solutions for things, like if someone was validating an email or something, it'd be like these crazy lines of like ASCII puke that like I don't understand what's going on, but it works and it's super short. So that was my like first exposure to it, that this is something cool that like programming wizards can do. And then I started needing it for some work I was doing. And I found this tool called Regex Buddy, which is a regex101.com is much better because it's free web tool that anyone can use. Regex Buddy is probably the best tool in the world for this, but it's I think it's like $40 and it's for Windows only. So regex101.com I would recommend more. But the Regex Buddy, at the time there weren't good online regex testers, not at all, nothing. They were like really shitty ones where you put in a regex and you put in some subject text and you submit it and it goes to the server and comes back and you can't see things that you type or there's no syntax highlighting or anything like that. The Regex Buddy had these core features that made the feedback loop faster, which is what I talked about, which made it actually fun to learn. Every keystroke you type, you're seeing what matches and what doesn't match. As you change the subject string, you see it like being matched in real time. These sorts of things made it really fun and I started playing with it more. And the other thing is I started like blogging about it, my discoveries, and I started to become like a little more known for it. That led me to like want to learn more, to be the expert on this. And there's sort of this feedback loop like that where I got deeper and deeper into it. And then actually from the blogging I was doing about regular expressions, the author of a classic computer science book called Mastering Regular Expressions, his name is Jeffrey Friedel. He wrote like the Bible on regular expressions. It was the only good book on them at the time. And he became a big fan of my blog. And then he offered to introduce me to his editors at his publishing company. So that's where it started, and that's where I started. And I wrote this book, Regular Expressions book. But yeah, it just started from like it actually being fun to play with them on my own. First needing a little bit for work, but then it being fun to play with because I had good tooling that made it fun and made it fast in real time. And without that, I probably wouldn't have done it.
Okay, so having a good use case and a quick feedback loop, those would be your
I think so. Having a tool that's good is absolutely necessary. So this website that I recommended is a good one.
Okay, thank you.
Okay, we have a question from Dan.
I'll try to be shorter.
He wrote on the chat, firstly, I'm impressed and I'm honored to listen to geniuses Steven Levithan, and I'm not from programming sphere, but I enjoy. My questions are, why still have left Facebook? For what you are using AI and neural networks? What exactly means industry expert? What are future occupation connected with the mechanical engineering optional? P.S. My camera and microphone are terrible. Congratulations to SAE Institute for this awesome event. So yeah, can we try to answer some of these?
Yeah, absolutely. Well, that's very kind of you, Dan. So I'll just go over your questions in order. Why did I leave Facebook? I'd been there 7 years. It was a good time for me for various reasons, but mostly the reason was I'd been there a long time and I wanted to try something new. I thought it was a great experience, but that was by far the longest I worked at any company. I think my longest before that was like 4 years, 5 years maybe. So like it was just, I'd been there a while and wanted to try something new. For what do you use AI and neural networks? I am not an expert at all in AI, so I don't use it for anything. Facebook certainly uses AI very heavily. They're one of the, probably Facebook and Google are competing to be the top companies in the world for AI. Google is probably number one, Facebook is probably number two, and then you have other companies like Microsoft and others. So they have, thousands of people working on AI, hundreds of people who are like world-class experts, famous in the AI space. They do all kinds of interesting things with it. I'm probably not the right person to get into it because that's not my area of expertise. What exactly means industry expert? So I can just speak for myself. At the time, I mean, it doesn't really mean anything, right? It could be just like bragging if I'm saying this, but I don't claim to be an industry expert on everything. I think there was this one narrow area of like JavaScript regular expressions that for years I was like very involved in, and actually, so like some of the symptoms maybe of being an industry expert on this is, I was writing programming books about this. I had the inventor of JavaScript, Brendan Eich. He was a fan of my regular expression work in JavaScript, and he invited me to like write the regular expression specification and standards for future versions of JavaScript. I had to turn him down when I went to Iraq, but that would have been a cool project. And like the people who were like at the top of their field in this were often coming to me with questions about this. So Jeffrey Friedel, who wrote the like Bible of regular expressions, he considered me a greater expert than him in some areas, like especially related to JavaScript. Brendan Eich, who invented JavaScript, considered me a greater expert on this aspect of JavaScript. So like these are some of, so I also like created a bunch of tools for this. The most popular like JavaScript library for creating more advanced regular expressions is something called XregEXP. I haven't updated it much for a number of years, but this is like a one-of-a-kind JavaScript library that's very popular, has millions of downloads a week on NPM. And this is something that I created as an open source project. I created like the best and most popular online regex tester for years. It's been replaced by better tools since I never updated it after like 2007. But I was mentioning before, at the time, there weren't good tools for testing regular expressions online. So the best thing was regex buddy, which is Windows-only paid software. But I created one that was like this, that was kind of like regex 101. It had some of the, like all the real-time matching, the syntax highlighting, all this cool stuff. Back in 2007, there was nothing else like it for a number of years. And now there's better ones, so that's no longer online. But yeah, so these are some of the things I was doing. So I think like in this narrow space of JavaScript regular expressions, I hope it doesn't sound too much like bragging, but I think I was like one of the more well-known experts within this space, where like if people had any like deep questions about this, I was, yeah, anyway, hopefully enough about that. What are future occupations connected with mechanical engineering? Mechanical engineering. Vladimir, maybe you can answer this.
Yeah, well, it is a little bit hard to answer, but generally the IT industry in general is changing the world so rapidly that, you know, like Oxford recently did a study and said that 80% of the occupation that exists today will not really exist in just 20 years from now, which basically, you know, like is obvious that these new technologies that we are you know, conquering and discovering and creating are basically creating new jobs. Now, to tell exactly what exact specializations within the industry will bring more jobs, I don't know. It's a very opinionated thing, you know. Like I'm a lot in machine learning, and I also did some you know, blockchain in my career, and I like to see these two fields like a very perspective ones, you know. Like I see them as something that will definitely be there for sure in the future, but it doesn't mean anything. This is just my personal opinion and from my personal practice. But what I know for sure is that, you know, like this is not going to fade away. This is not going to decline anytime soon, you know. Like every day we are you know, having more and more devices around us that are doing different things, and with more devices there are more needs to people to create interfaces and programs and algorithms behind these technologies. So what I see is that that majority of profession one day will become somehow, you know, somebody recently said IT is not even an industry anymore. It's a part of every industry. Actually, it's becoming a part of every industry. So this is, I think, a very good perspective on this problem. Okay, guys, anybody else? Do you have some questions?
Yeah, I have one more actually. Could you please tell me, Stephen, what was it like applying for a job at Facebook? Was it difficult to get a position, and would you say it's difficult to get a job at Facebook? Or let me rephrase the question: what type of person does Facebook want?
Yeah, it's a great question. You know, I mentioned that I don't actually have a background in computer science. Facebook was the first big company I worked for. I didn't actually, you know, on paper, I'm not that. Maybe for JavaScript regular expressions, I'm really good, but for other things, you know, I'm not some rock star programmer. And I had my own self-confidence issues on this, etc. I think. So these the big Silicon Valley companies, their interviews are often very like algorithm focused. Like, so having a more traditional computer science background is definitely helpful. For me, so they actually reached out to me. I didn't contact them. I was in Iraq at the time, and they actually no, this was later. But anyway, I was on, because of my blog, I had someone there that was a fan of my work who added me to like a list of JavaScript experts for help with things. And Facebook recruiters looked through this list and they contacted me. So they reached out, and so this is what I was mentioning earlier in the talk about, like actually demonstrating your expertise online somewhere, whether it's through open source or blogging or other things you've done to like to show your passion and expertise on projects that you've actually built can be good, because like this is what recruiters are looking for. I think like at least I can only speak for Facebook, but I think they don't really accept like cold submissions of resumes. because the acceptance rate is just too low. So it's not a good channel for them. So what they have various things, like either their large recruiting team will reach out to people, or they will, maybe you like competed in some like coding competition, or there's a variety of channels. I'm actually not an expert on like what the recruiting team is looking at for signals. But in my case, they reached out to me, invited me for an interview. I'd gotten reach outs from other big companies before as a result of blogging. So that was one way to get my name out there at the time. So Facebook reached out. I went over to Menlo Park for an interview. I was fortunate in, I feel, in getting a job there initially. So over time, I did well, and I think it's a very mutually beneficial arrangement. But to start, there were many things I didn't have. I had never worked in a big Silicon Valley company like this. There were things I had to learn. So if I did their traditional interview, it's possible I would have failed. I was fortunate that they actually had a program where they were looking for like deep browser and JavaScript experts, and they had a separate, mostly because you choose your own team when you start as an engineer there, mostly they have like the same interview process for everybody, because then they want to have a consistent bar so you can work on anything you want. But they did have a program where they were looking for like, their existing interview process was failing a lot of like the top experts in browsers and JavaScript, because a lot of these people were self-taught and didn't have computer science backgrounds. So they created a separate program they called like user interface engineer. And so I went through this interview process, and that was my domain. Like I knew everything about browsers and JavaScript and stuff, so that I was able to do well at. But yeah, that was the process. If you have any follow-up questions about that, I'm happy to answer. But yeah, when I started, it was intimidating at first, and then over time it got easier, and then it got fun, and then. Okay.
That's all right. Thank you for the answer.
I've got one, very simple one maybe, but what would be the key advice that you would give yourself as a beginner in programming in general?
Question. I'd be interested in other people's take too. Maybe I can give this to Vladimir afterwards. But yeah, I think it's to have fun with it. I mean, that's like for me at least. That's how some people start it, because they know it's a good career and they're motivated by that it can pay well. I would also say it's a good career in that like people work on meaningful, interesting things that are often like quite creative, and it's actually like it can be a good work experience. In addition to paying well and having lots of opportunity. So but for me, that's not what I was driven by originally. I was a geek, and I loved computers, and I loved everything about them. Like I mentioned, I didn't even start with programming. I was doing like computer graphics, and I was doing computer repair, and anything related to computers was great. So for me, it was always about having fun. I switched into programming because it was even more fun and it was even more creative. So that's part of what I was talking about with like fast feedback loops, help make it more fun and help you stick with it, is another thing I would recommend as well. So for someone who's trying to get into programming and they heard that like writing C is a great opportunity because there's lots of jobs for this, I would not recommend starting with something that's gonna be like more challenging to learn. I think you want to start with something that is easy and fun to learn, that you can see your results right away. There aren't as many concepts to learn all at once before you can produce anything that you can see and share with other people. I think if you can make something for yourself that solves a personal problem or a problem for a friend, and you can share it with your friends easily, that is a great way to get started, because you'll have fun, you'll learn enough to keep you going, so you learn even more, so you become an expert down the road. So yeah, that's what I would recommend to new people. That's why I talked about like mentioning JavaScript as the first language. There are other great answers, like Python's maybe a good first language, maybe Go, maybe like there's lots of good options, right? But PHP. But for me, JavaScript I like because you can, without having to learn, fancy IDEs or compilation or tooling systems or whatever else. I mean, those things are recommended for good JavaScript programmers, but you can start really simple in just a text editor and a web browser and no web server or anything else.
Thank you.
Okay. Let's maybe have one more question if there is, and wrap it up here, because we are already spent the time. So is there anybody else who would like to ask anything? No? Okay. In that case, I'm really, really happy. I cannot express enough how I was actually, happy to hear this story. I mean, it's a very interesting story, and sometimes the people, because sometimes I talk with my students, and tell them some of these things, you know, from a different perspective. And now they had another perspective to hear, you know, but mostly saying similar things. So I think it's it's a very interesting experience for some of them, as well as it was also a real pleasure to have somebody like you, you know, telling us about. We had a guy named Relja Petrovic who was also working at Facebook, and I don't know if you maybe met him. It's he's a Serbian guy who actually left Facebook in 2014 or 15, something like that. Do you maybe know him or not?
I have not met him. I do not know him, but I do know other Serbian programmers at Facebook.
Yes, yes, they are Serbian programmers there. So I mean, you know, like when you say Facebook to a junior programmer, you probably, you know, like it sounds like a dream come true, I suppose. At least it sounds really like a really exciting thing. So generally, you know, like hearing this from the first source, you know, like you, it was very precious. Thank you, Steven, very much. Thank you, everybody, for joining and you know, participating in this session. I think it was very, very useful, and I wish we will soon repeat something like this. So.
Well, thank you, Vladimir. Thank you, Dragan. Thank you, everyone, and everyone who asked questions as well. Well, this was a lot of fun.
Thank you. Thank you very much. See you some other time, guys. Bye.
Bye.
Thank you. Bye.
Bye. Thank you.
Bye bye.